Morning to everyone. Thank you for being here today, and I would like to thank the organizer and especially to Daikin for inviting me to this great conference. I will start with a story. Imagine you go to the gas station, you fill in the tank, you go to the register, and the guy, the cashier, gives you 50 bucks. And he says, "Thank you so much for helping us get rid of this gas." So when you leave the gas station, you are 50 bucks more rich than when you came. I know this sounds like science fiction, but I want to show you today that there are opportunities such as this one in energy field, and they will be happening more and more in the future. Opportunities that you can, your companies, your families can benefit from. I'm professor and head of laboratory for energy efficiency, and I know when you hear professor, you're like, well, these guys have no clue about real life, which I'll admit is true in most cases, but I would like to offer a bit different perspective. Because as someone who is a professor and a scientist, I really collaborate with institutions around the world, and I get exposure to the newest findings in the world of science and technology, things that will be applicable 5, 10, 50 years from now. But also I feel first and foremost like a mechanical engineer. So I dedicate my work and the work of my laboratory in collaboration with industry, helping them with transfer of knowledge, helping them develop new products. So I understand quite well that CEOs and investors don't talk as much about sustainability. They talk about return on investment. They talk about how to create best products for their companies. So it's my job to try to find a win-win situation for both of them. Unfortunately, in energy industry, we talk a lot about sustainability, but there is also a lot of greenwashing happening. Greenwashing is when a certain technology or a service or a company is being promoted as sustainable, but in reality, that's marketing. That's just not true. In energy industry today, there is no golden bullet yet. There is no one technology that will help us, save the planet. And whoever claims otherwise either doesn't understand the scale of the problem, or is just in love with particular technology, or just has some ulterior motives that I won't go deeper into today. But energy field is quite complex. So focusing on one technology, on one stakeholder, I think is a complete waste of time. We need to look at the whole picture that is really, really quite interesting, and there's a huge potential happening looking at the whole picture. Before I get deeper into my presentation, I just want to ask you, think about for yourself, what is the most important fuel today? I will answer this shortly, but before we answer that question, let's look at how we use fuel today. Of course, majority is conventional fuels, and then minority of it is renewables. And you can hear claims such as, well, we will solve all our problems when we go to 100% renewables. But reaching 100% renewables is not an easy task. Implementing renewables after a certain threshold is becoming a real technical and economical issue. And I will try to talk briefly, just briefly about it, just about one issue. Here on the map, you can see the percentage of renewables for different countries worldwide. Croatia is actually doing quite well, being on 18th place in the world because we have a lot of hydro energy. Place number 1, Iceland and Norway. But what is really interesting for them, they have renewable sources that are quite stable. Those are hydro and geothermal. Germany, on the other hand, is implementing more and more solar and wind. Renewable sources that are known to be unpredictable and that are quite volatile, fluctuating all the time. And there are severe difficulties, technical challenges happening in the grid due to that fact. As an example, this is 1 month, it's in April 2020, showing production side and the demand side. So demand side are buildings, electrical vehicles, industry in Germany. You can see with green here showing the energy production from renewables, with green energy production from conventional sources. Yellow line shows your demand side, so buildings, industry, and so on. And as you can see, surpluses of energy happening in the grid due to overproduction of energy. Surplus, you can resolve it, either you can store it, which is still quite expensive. I'm not talking about hundreds of thousands, I'm talking about millions and billions of dollars that have to be invested for these type of technologies. Or, of course, you can sell it to someone. And this is precisely what has been happening in Germany in this month. So you can see prices of electricity actually being negative for certain parts of the day. This will be happening more and more in the future as we have more unpredictable renewables in the grid. If you're an intelligent building, you can definitely use these times of the day, not just to reduce your energy bills, but also to earn some money while doing so. And I will talk about some technical potential and how we can achieve that. To answer the question, so what is the most important fuel? According to International Energy Agency, we consider energy efficiency to be the first fuel, as it still represents the cleanest and in most cases the cheapest way to meet our energy needs. So when someone talks about renewables without talking about energy efficiency, for me it's like, talking about how to fix a faucet without thinking how do you fix your bucket that is leaking. You can have a golden faucet if you wish, but the bucket is still leaking. So most of my presentation will be focused on buildings today because I believe they offer great potential and offer a win-win-win solution for all of us, and I will show why. According to the United Nations document that was published in 2009, the building sector has the most potential for delivering significant and cost-effective greenhouse gas emission reductions. Why? Well, first of all, buildings have long-term impact. If you make a bad car, it will be on the road for 5, 10, 15 years. If you make a bad building, it makes troubles for decades, sometimes even 100 years to come. This is an average age of building stock in Europe today. Also the magnitude. I find this to be a remarkable fact, but we put one New York on this planet each month in a year, and we will be doing so 50 years to come, 40 years to come. So one New York each month. Also, buildings are responsible for almost 50% of greenhouse gas emissions. First, because of energy that we are using in buildings, but also energy that we're using to create all those materials, concrete, solar panels, and so on. Also, in addition to energy, of course, the most important part is the fact that we spend majority of our time indoors. I'm sad that I have to disappoint you, but we spend 90% of our time indoors. So looking at 1 year, on November 15, you would leave your building, and then you would spend minority of time in car and outdoors. Also, what is really disappointing is that today, with all the great technologies, we literally still have buildings that are making us sick. Maybe you think it's just 1 or 2 or 5 examples in the world, but in US alone, there is almost $300 billion being lost because people are either less productive or they're taking sick days because their HVAC systems in buildings are not functioning properly. Also, in buildings, there is a huge potential for improvement. In buildings, 80% of the potential for improvement is still being untapped. 80% of the potential. Also, there is a huge potential when we talk about intelligent buildings. Today we talk about smartphones, smart buildings, smart everything. But when someone is presenting me a smart building and when you ask them, so what is actually smart, you will often be disappointed. Because what those buildings are doing, they're collecting a bunch of data, they're showing nice graphs, but unfortunately there is no data analytics. Nothing is being done with the data. There is nothing super smart about those buildings. Because of that fact, European Union just a few months ago published a document trying to quantify intelligence of a building. So your building can be 0%, 20%, 100% intelligent. 100 is the maximum. So I have used the methodology and I try to calculate. Imagine the newest building with all the sensors, with the newest control system, showing you all the nice graphs. What's the intelligence of your building? And the answer is 30%. So again, there is a huge potential in achieving great solutions in buildings, both in terms of energy efficiency, but also in terms of smartness. So I hope that I have at least starting to convince you that by investing in buildings and thinking about our solutions in buildings, you can actually do a win-win-win. You can help people around you, you can definitely help the planet, and you can also earn some money while doing so. This was theory, but I would also like to focus on the practice, how this looks in the practice, what is some interesting research, what are some interesting projects that are currently happening in this industry. So when we talk about projects in terms of collaboration with industry, my laboratory focuses on development of optimal concepts at the beginning of the project. So imagine a new building. When you have bill of quantities, there is little you can do by negotiating the price of final equipment, whether it's like 20% or more cheap or more expensive. It's too late. The moment to think about what is the optimal and when you can achieve the best benefits, the best value for your buck, is at the beginning when we think about concept phase. So having only architects thinking about the building at this phase, I think is a complete failure. We work on projects from the first phase, from the concept phase, and one of the latest projects is a project I'm sure many of you have heard about. It's a newest campus for Rimac Group. It's probably one of the most complex I've been working on. It's because of its size, so it's 100,000 square meters, but it's also very complex in terms of usage. On this building, our goal, the goal of my team, was very simple. So we had to find energy concept for which investment cost plus 10-year operational cost is minimum. But also investor was very clear about some additional requirements. So they were very keen on having very flexible site. They wanted their co-workers to be productive, and they also had huge focus on sustainability. I won't have time today to go through all interesting analysis that we did here, but I will show only a few. So our main goal was to go from left picture to the right picture, to show that you can replace conventional fuels with renewable sources. So the whole campus will be heated and cooled using air source heat pumps. Also, we did a lot of optimizations on this campus. I will show only few results. So optimization on insulation. This was actually optimization that lasted for like 10 or 15 minutes. But if you know what you're doing in 10 or 15 minutes, you can definitely achieve great benefits. So more than 10 million kunas being saved only on insulation and also substantial amount in operational cost. Also, investors are usually interested how much additional is the cost if I want to have the best possible ventilation system. Clearly, if you are bringing a lot of air in the building, your occupants will feel much more productive, they will be more healthy, but that costs money. That costs something in investment cost and also in operational cost. Here, I cannot show the real numbers due to confidentiality agreement, but I can show this, where you can see clearly that the cost is incremental between the best category of ventilation system and second best. So this is clear indication for the investor that he should definitely go with the best type of ventilation system. And this is our job, trying to quantify different things so investors can make informed decisions. And of course, most investors, including this one, is asking us, if I want to be carbon neutral, if I want to be net zero energy building, what's the additional investment that I have to make, for example, in covering my roof with PVs? And currently, so this is a project about new building. We are also doing a lot of projects on refurbishment. So currently, for example, we are looking at 7 buildings at Faculty of Science, PMF, in Zagreb, trying to make optimal strategy for energy refurbishment of those buildings that are currently all on gas. Also, in addition to projects in collaboration with industry, there are many really interesting scientific projects that are currently happening in the lab, and I would like to show them today because that will shed a light where the industry is going, where the future of energy field is going. So we are currently building our future playground. It will be a living laboratory where we want to test all the technologies, strategies, control algorithms that we are developing. It's a building that is being built in collaboration with Technical School Ruđer Bošković. It's funded by European Union, and it will actually be used as a school building, but also, as I said, as a testing platform for many different technologies that in the laboratory we are developing. In this building, we are hoping to achieve 3 years from now level of intelligence going from 30% for new building to more than 90%. And you can ask, so, how are you overcoming the gap in 3 years? Well, it's because European Commission and their document is putting a huge value on responding to user needs, not just energy efficiency, but how do you respond to user needs in efficient way, real time, but also how do you help the grid? How do you help offset those surpluses of energy and help reduce your energy when there are just peak consumption in the grid? We are doing this through very specific type of control called model predictive control. It's a control where you're looking what will be happening 24 hours ahead, not just now, but you're predicting 20 hours ahead and you're optimizing real time. This is something that is being done mostly in simulations, and results showing that you can save from anywhere from 5 to more than 40% of energy using this type of control. Unfortunately, still not much experimental work happening. This is something where we are hoping to change this. And Nicola Bajun, my PhD student, is developing a strategy that will be used not just on one building, but we are looking at how to scale this on 100,000, 10,000 new building. And this is done in collaboration with the Lawrence Berkeley National Lab. It's a national American lab, and also with the Technical University of Delft. Nicola is also looking at what's the sweet spot. So obviously you can invest more and more, but after a certain point, there is no point in investing more because you see only incremental implementation benefit. So he's really trying to find a sweet spot for a certain project. Arlinda Bressa is another PhD student. She is looking into communication between people and artificial intelligence. People who are in this field, they just assume that users will give their feedback and the control system will, based on that feedback, optimize the building. But as a user, I do not want to give my feedback. I want my building to magically knows how I'm feeling, what I need, what's the temperature, what's the humidity, what's the light. And I also want somehow, when I go from my home to my office, for a system to magically, transfer my little avatar to my office and also set up all the parameters. This is precisely something that Arlinda is developing through machine learning and, again, data analytics. Ružica Budim is also a PhD student who is looking into potential for demand response. It's a very complex topic, but simply said, when more and more buildings will be smart, there is a huge potential in helping the grid. So what will be the possibility of doing so, and what will be some technologies that will probably be lower hanging fruit and that will have the huge benefit in the implementation. Lucia Magdic and Franco Čurčin are starting to work on the model predictive control for a fleet of autonomous vehicles. Clearly, there is a charging and discharging pattern that can be optimized. So again, if we just know what's happening now, well, that's a certain, that it's fine. But if you can somehow predict what will be happening in the future, specifically on the energy grid, then you can actually benefit from that a lot. And finally, this is Borut Omerzo. He's a PhD student working on ventilation strategies. When this whole pandemic started, we actually realized that we don't know much about ventilation. Actually, we don't know much about many things. So Borut is looking into different ventilation strategies as a preparation for, we hope, not the next pandemic that will come soon, but when it comes, we want to be more prepared than we were. This is work that is being done in collaboration with MIT and also Massachusetts General Hospital. He's running computational fluid dynamics simulation, quite complex simulations, but also supported by experimental work. And I will conclude just by stating 3 key lessons. So maybe you'll forget everything I said today, but I would hope that you will remember 3 things. First thing, if you're looking at a new project, a new building, then don't look at the bill of quantities. It's too late. Think about how to make the best solution at the beginning, in the conceptual phase. This is where you can achieve the greatest value for the project. The second one, if you are thinking about the investment, about new businesses, then definitely the future of energy field is not about the specific technology. It's how do we make all these stakeholders, all these technologies communicate and optimize them in real time. That means optimizing them each second, each minute, each day. And finally, by thinking smartly about all these questions, not focusing on, all different, not just clearly thinking about what's greenwashing and what is really efficient, what is really right solution, you can achieve great benefits. There is a huge power of choices in what you're doing. You can save money, you can help people around you, and you can definitely help the planet. So I encourage you to make smart choices. Be smart. Thank you very much.